Hello everyone, welcome back to CHM 577. So in this part, this is part 2, where we will be discussing more on the Electron C or cloud model. This is where we discuss on how this Electron C or cloud model form. Alright, so the simplest way of explaining metallic bond is by assuming that the metallic lattice is composed of a closely packed positive ions surrounded by electron C or electron cloud. So this happens when metal atoms lose their valence electrons. So of course you know that metals have a tendency to release or to donate their electrons, okay, forming metal cations, and the valence electrons then made up the electron C or electron cloud. Alright, so in metallic bonding, it involves a lattice of positive ions surrounded by delocalized electrons. Okay, so metal atoms usually achieve stability by offloading the electrons to attain the electronic structure of the nearest noble gas. So these electrons join up to form a mobile cloud, which prevents the newly formed positive ions from flying apart due to the repulsion between similar charges. As you know, if we have the same charge, they usually will repel. But this does not occur in the metallic bond because of the presence of delocalized electrons. Right. So in this diagram, okay, the atoms arrange in regular closed packed 3D crystal lattices, and this is where we have the formation of the positive ions and also the formation of the electron cloud or electron C. Okay, alright, so the outer shell electrons of each atom leave to join a mobile cloud or C of electrons, which can roam throughout the metal. That's why they are being called as delocalized electrons. Okay, alright, so the electron cloud binds the newly formed positive ions together. This is where the metallic bond will be formed. Alright, so the metallic bond strength is actually has two factors, okay, that affect the strength of the bond. Alright, the first one is it depends on the number of outer electrons donated to the cloud, and second one, the size of metal atom or metal ion. Okay, so in this I have one example. Okay, let's say we have a sodium, we have potassium and also magnesium. Alright, so the least strong of the metallic bond is the sodium. Okay, the second strong is the potassium, while the magnesium is the strongest, okay, in this among these three elements. Okay, why magnesium is the strongest one? Because, okay, this atom has donated 2 electrons, okay, to the cloud. So the greater the electron density holds the ions together more strongly, and then the strength followed by the second stronger the second strongest, okay, the second strongest metallic bond is potassium. Okay, so this potassium is slightly weaker than the sodium because the resulting ion is larger, and the electron cloud has a bigger volume, okay, compared to the sodium, where the stronger where the bond is relatively weak, okay, because each atom only donates 1 electron to the cloud. Okay, then next, okay, the strength of this metallic bond is actually inversely proportional to the size of ion. Okay, alright, and directly proportional to the number of electrons. So it depends on the size of ions, okay, right, and also the larger number of valence electron. Okay, then the smaller the size of cation, the more electrons supplied by the atom to the electron cloud, and the stronger is the attractive force between the positively charged ion and the electron cloud, the stronger is the metallic bond formed. So across the periodic table from left to right, okay, there is an increase in the strength of the metallic bond. Okay, so in this I have one example. Alright, here we have we have sodium, we have magnesium, and we have aluminium. So as you know, sodium will be releasing one valence electron, while the magnesium releases 2 electrons, while the aluminium releases 3 electrons. Okay, so in terms of the strength of metallic bond, okay, aluminium will be having the strongest metallic bond, followed by the magnesium and also sodium. This is because, alright, the more electron swims in the electron sea or cloud, okay, the stronger is the attractive force between the electron cloud and the increasingly positively charged metal ions. For example, aluminium 3+ here. Okay, therefore the stronger is the metallic bond produced. And then as the strength of the metallic bond increases, okay, the values of the physical properties such as melting point, boiling point, and hardness are also increased. Okay, so that's all for this part 2 on the formation of electron sea or electron cloud model. So I'll see you in part 3. Bye.